Alright, welcome to another Random Bits video. Today we have something I stumbled across on eBay quite by accident. This is a Z80 single board computer made by a company called Insight Enterprises. Initially I could only find 3 references to a Z80 computer made by an Insight Enterprises, 2 ads that appeared in the back pages of Byte magazine, and a cute little diatribe against the company name by one of the editors of Microcornucopia magazine. That's it. I did another search with just the company name, but apparently someone else is operating under that name today. I highly doubt it's the same company. I then added the former address of the company shown in the ads, and that managed to produce 2 more ads, all basically the same copy, although one was offering what looked like an early bird discount. The descriptions all seem to describe the board that I have on my desk here, but they all look different. The specs stay the same, but all the ICs are in different places. What gives? The Microcornucopia piece is a bit more helpful. It says, "I have trouble with this name. It doesn't flow." Sure, buddy, Microcornucopia just glides off the tongue. Also, it breaks the rule about using enterprises. You know, I didn't know there was a rule about using enterprises, but I'll be darned, it's right there in the Geneva Convention. I hope I haven't contravened that particular rule in my travels. I'd hate to be a poor global citizen. Oh wait, this bit looks kind of relevant. I also understand they have gone out of business. This article dates from late 1984, and it appears the first of the Insight ads hit around January of 1983. So yeah, this company didn't have a long shelf life apparently. That's too bad. The specs they list off here actually seem pretty decent. We've got 128 kilobytes of dynamic RAM, 4 kilobytes of static RAM for the onboard video, DMA, a saucy hard disk interface, a floppy disk controller that can handle up to 4 5.5 inch or 8 inch disk drives, doesn't matter, 4 serial ports, and a full Centronics printer port. Also says there's an expansion bus. Oh, and it can do wide line and thin line graphics, whatever that is. And it's a compact size, you know, in case you want to tote it around in your purse. One thing that gives me a chuckle though is the tagline on this ad. Attention big board users, why use outdated technology? Ooh, shots fired. Actually, that's kind of like the most niche attack ad I've ever read. The big board, if you don't know, was a single board computer produced by Jim Ferguson of Digital Research Computers, not to be confused with Digital Research Systems, which produced the CP/M operating system for computers like these. Actually, I think Ferguson actually changed his company name later to spare the confusion this created. Anyway, in 1980 when the big board came out, the whole hobbyist movement was kind of running out of gas. Computers were becoming much more appliance-like. People didn't buy them out of a deep interest in electronics technology. They bought them to do stuff like play games, word processing, and what have you. They didn't get a tickle up their leg thinking about soldering capacitors and IC sockets for hours on end. They really just wanted to unbox it and really put the use in the word user. And increasingly, even the hardcore electronics nerds were joining the bandwagon. Why spend months hunting for parts and burning your fingers with your soldering iron when you didn't have to? Jim's so-called big board was kind of a counterculture statement. It was a machine for purists, like those guys that prefer a stick shift over an automatic, or people who were simply on a budget. You could buy the whole kit, I think, for about $300. That compares to that fruit-named computer rather favorably. Yeah, I mean, you had to build it, but think of the savings, and, you know, all the fun you were going to have. Anyway, the big board did really well, all things considered. So well that Xerox actually licensed the design so they could flog it for 3 times the price to a thoroughly disinterested business clientele. Personally, I kind of consider the early 80s to be the end of the classic era of kit computing. I know, we're still building them now, but it's not the same. It's a matter of debate to be sure, but as a collector, I consider the dividing line between the classic and retro eras to be the moment when one no longer needed to build a home computer from scratch, i.e. there was no cost advantage or compelling reason to do so. Of course, we still build these things today, but it's mostly for fun, not necessity. This Insight board, I think, was kind of straddling that line. I've always loved history, and something I've always found fascinating are transitions from one regime to another. It's interesting to look at how people and organizations respond to upheaval, like the end of the Roman Empire or Revolutionary War America. The same is true in computing. I find the transition period from CP/M to PC/MS-DOS particularly interesting. Many companies were trying to figure out which camp would be victorious and place their bets accordingly. Some tried to stick with the old regime, some went whole hog for the new, and a few tried to have one foot in each camp. I think the Ferguson was definitely old regime. It appealed to the original adopters of the personal microcomputer, the hardware nerds. It ran the only mainstream operating system the world had known to that point. It was back to basics. I actually have a big board in my collection, or rather a big board too. It's a redesign, but it's basically the same machine. You'll note the board is quite a bit bigger than this Insight board. Now, I said the big board was successful, but it wasn't McDonald's successful. The VIC-20, which first went on sale in 1980, probably outsold it by hundreds of thousands. So it kind of seems like a rather small market to be chasing, following a design paradigm that by 1983 was clearly on its way to extinction. But I guess you gotta give Insight some credit for trying. I wonder what was going through their minds. Were they aware that they were potentially sailing into oblivion? Or did they, like many of their peers, scoff at the notion that CP/M would go the way of the dodo bird? Insight's offering is sort of stuck between the world of kit building and fully manufactured computers. It's not a complete computer by itself, but it appears the mainboard was offered fully assembled. No need to get your hands dirty. At least, I hope it was. At $750, that's twice the price of the Ferguson kit. You still had to find all the other components yourself, like keyboard and power supply and stuff, but at least you didn't have to solder the thing together. Actually, it looks like Insight was looking for OEM-type companies to enter into licensing agreements and have them build their own versions. Now, the ad copy itself is pretty consistent from ad to ad. At the bottom we have the IEC logo and the company's address on Northwestern Avenue in Los Angeles. But the pictures are what confuses me. Why do we seem to have two different designs featured in the photos, and then my board, which isn't similar to either? You can see pretty clearly that all the major ICs on these three boards are in different locations. So what's the deal here? I kind of think this board may actually have been a prototype or maybe a pilot unit of some kind. It's impossible to say without verification from someone in the know, but let's look at a few elements I think that point to prototype status. First, check out the jumper wires here. Now, that's not at all unusual to see on production boards. I happen to have an early Tandy 1000 motherboard that has a few blue jumper wires scattered about. Sometimes companies prefer to do that versus scrapping boards with errors in them. It saved a lot of money. So yeah, that's not really proof of anything by itself. The revision, however, seems to point to earliness also. Revision A. Prototypes aren't always assigned revision numbers, but when they are, they usually start at 0 or A or whatever the lowest letter or number is. Then we go down to this little handwritten note here. Kind of appears to be a serial number. It's very low if it is. IE 118. Now, I don't think I'm stretching the imagination to imagine that IE stands for Insight Enterprises, and 118 is probably the serial number. Again, this doesn't prove anything by itself. Apple II motherboards, for example, had handwritten serial numbers and date codes for years. However, it does kind of make it seem like this might have been an internal use board. It's possible, of course, that for the sake of having something to show in the ad, they simply used a prototype. Companies sometimes did that. They'd put out an ad before everything was nailed down just to gauge interest. Sometimes what was advertised was never even actually produced, hence the term vaporware. What's odd in our particular case is that what we're seeing here are three essentially different designs, including mine. That seems a bit excessive in terms of the resources required to produce those three different designs, especially for some podunk Ferguson wannabe company. Another possible explanation for this board is that it might have been a pilot unit. A pilot unit is something you produce when you have pretty much 95% of the design nailed down, and now you want to see how it actually comes out from the factory. That gives you a chance to test manufacturing practices and catch any last-minute defects. I have an Atari Falcon that, according to Atari, is a pilot unit. It has a motherboard with an extremely low serial number of 7. You can see it looks a lot like a standard Atari Falcon, although the case plastic is a little more like the ST, and the keyboard is the white ST keyboard rather than the dark gray we saw with most Falcons. When Atari started production of the Falcon, they had a few different companies producing these pilot units for testing and demonstration purposes, and they probably didn't have all the pieces that would give the Falcon its distinctive look ready to go yet. The company that made this pilot unit wasn't selected for actual production. So that's certainly a possibility. Unfortunately, unless some former Insight Enterprises person comes forward, we may never know. Anyway, for this video I thought it'd be fun to do some exploratory work and try powering this thing up. Some digital archaeology, if you will. This will be inherently tricky since we're lacking any sort of documentation, so there's a good chance that this won't go anywhere, which is why I'm doing this as a random bits video, just to hedge my bets. Now, I should be clear that I am no electronics guru. I'm a longtime collector who, like most collectors, has had to do some repairs all by my darn self for occasion. You pretty much have to learn this stuff if you want to keep your vintage collection going. It's not like you can take these things to Geek Squad. But that said, after 20 years, I would hope I've learned enough to scout out something like this a bit and at least breathe some life into it. If this thing really is a prototype, it may not work at all, of course, so I can blame it on that. But I'm somewhat hopeful. I would say about 90% of the vintage gear I receive ends up needing only a little bit of tinkering or nothing at all to be somewhat functional. Anyway, let's set a couple goals for this video and see where we end up. The first goal is to power it up and get something on screen. That alone would be a huge victory, and it'd be really cool to see that since I'm sure almost nobody has seen one of these things operating anytime recently. To get the machine powered on and displaying something, we basically just have to figure out the power connector, which should be simple enough, and then find the ground and video pins for a composite out signal. It's possible this machine doesn't output composite, but I doubt it. A lot of people back then had composite monitors, and it was easy enough to make provisions for both. The second goal would be to interact with it. That would involve hooking up a keyboard, and it's way more ambitious because we have a lot more moving parts to deal with. The ad suggests we can use a parallel or serial keyboard, and I assume the coding it uses would be ASCII since that was the standard by this time. But that means that we also have to find a whole bunch of pins to plug into in the right order. And there's a strong possibility the computer may not have, say, a system monitor like the Ferguson does. On the Ferguson, you don't need to boot into an operating system to use it. You can drop into the system monitor and do things like edit memory contents. Since the Insight folks seem to be targeting Ferguson users, I would hope they'd have that sort of functionality, but they may not. The computer may simply wait forever for a boot disk we'll never find, and not allow any keyboard input in between. So that would make verifying the keyboard is working pretty darn difficult. Yeah, this one might be beyond my pay grade, but I'm game to try. Anyway, let's dig in. Obviously, with something rare and unusual like this, we want to take extreme care. We want to look around the board and just make sure there aren't any super rare proprietary chips that could be destroyed if we say, connect the wrong power supply voltages. Looking at this Insight board, I don't really see anything proprietary. That was still kind of the norm back then. But I do see this Insight labeled EPROM here. The EPROM itself won't be anything unobtainium, but the contents of the ROM will be. For all we know right now, the contents of this EPROM may be the only existing copy of that information left. The EPROM likely contains the basic bootstrap loader for the machine, maybe a system monitor, and possibly also handles character generation, as I don't see a dedicated character generator on the board. Since it's in a socket, it's easy enough to remove it and dump it so we have a backup. That way, if I inadvertently blow this thing up, at least it can theoretically be rebuilt. So let's back this sucker up before I even start here. Okay, so I've got our GQ4X4 universal programmer here. I bought this probably about a year ago. For some reason I was really stubborn about not having an EPROM programmer, but I finally did it and I'm really glad I did. It comes in handy a lot, especially for stuff like this. So we've got our chip here, and the part number appears to be, I think it's a 2732 with an Hitachi part number. It's a little bit of a long one. Going on memory, I feel pretty confident that's a 2732. So we'll put it in our EPROM programmer here. And then we'll load up the software. All right, so let's fire up our programmer software here. And there we go, we're ready to go. So we just gotta select our device, which is the type of chip it is. And at least from what I've read, it should be a 2732A, so let's just select that. All right, let's do a read. We'll see if there's anything on it. Yeah, there's stuff on there. Let's just scroll down a bit here. Oh, look at that. EQ4 equalizer ROM loader. Rev 1.1A 06/18/1983. Okay, so we're on the right track here. I can't make out, I don't understand any of the rest of this. But like I said, I'll post this in the video description. You can have a look through it if you want. Quite a bit of stuff here. And then we got letters and numbers. I don't know what that's all about. I'm guessing, I didn't see a character generator anywhere on the board, so I'm kind of guessing that this EPROM is doing double duty. It's acting as both the BIOS firmware monitor, whatever you want to call it, and also as the character ROM. Maybe these are different fonts that it uses or something along those lines. So yeah, well that's good. That means that hopefully the data on this is all good. So what we'll do is we will save it, and I will save it as a bin file, Z80. So that's the bin file, and then I'll also save it as a hex file because those are a little more useful for some people. Okay, so that's basically that. Now we've got this EPROM backed up. So hopefully whatever trouble I do get into, if I get into some, at least I've got the precious code saved and the computer can potentially be revived. All right, so let's get back to the bench. Okay, now that we have our backup safely on the cloud, let's sort out power and see if we can actually breathe some life into this thing. I'm not 100% certain, but I'm pretty certain that the Molex connector to the upper right with the 4 pins is likely the power connector. Those are usually pretty beefy. Figuring out which voltage each pin takes isn't rocket science. If we know what devices are on the board, we know what voltages need to be present. It'd be a lot trickier if the board had voltage regulators and stuff, because that would mean the incoming voltage might not be the standard 5 and 12 volts that we're used to. But I don't see that here. Probably it's just expecting a DC power supply supplied by you, the user. There are 4 pins on the connector, so we know one of them likely has to be ground, probably this one that ties into this fat trace that's running around the edges of the board. That leaves 3 other voltages we have to find. Almost certainly one of those will be plus 5 volts. That's what a lot of this 7400 series logic uses. This is also a good opportunity to make sure there aren't any shorts on the board between the power rails. If my multimeter shows any connections between the power pins, we know we might have a problem. Finding 5 volts is easy. Basically, we take our multimeter and we switch it to resistance mode. And then we place a probe on one of the power pins and put another probe on the 5 volt pin of one of the 7400 chips, one that we know will be expecting 5 volts, which would be pin 14. Aha! Victory on the first pin. The 5 volt clearly connects to the lowermost pin. I'll make a note of that for future reference. Ground should also be easy. We know that that comes to pin 7 on a lot of 7400 chips. So let's use our probe here and see. Yep, there we go. There's ground. My hunch was correct. Okay, so that leaves 2 mystery voltages. Or are they? I've been working with vintage machines like this for a while, and I know that on most of the designs where serial ports are involved, you typically need 2 voltages, plus 12 volts and minus 12 volts. And a good place to look for those are line driver ICs like this Motorola MC1488. The 1488 is called a line driver because it's used to amplify and send the serial communication signals out from the computer to whatever device is connected to the serial port. There's a complementary MC1489 which is called a receiver and correspondingly brings in data from the remote device to the computer. The MC1488 is particularly useful in our hunt for power since it requires those 2 voltages, one negative and one positive. A quick look at the MC1488's datasheet shows the positive voltage, or VCC, comes in at pin 14. The negative voltage therefore comes in at VEE, or pin 1. Now, it's not a sure thing that the MC1488 is using the 2 voltages I suspect are the remaining voltages we need to find, plus 12 and minus 12 volts. The MC1488 can actually take a range of voltages up to 15 volts. But in this era of design, it was much more common to use plus and minus 12 volts. Plus, there are other chips that we know for sure use plus 12 volts that we can check with our multimeter to see if they link up with the suspected 12 volt pin on this MC1488. If they do, then we've nailed it, and it's almost certain that the other side of the MC1488 is minus 12 volts. So first we'll connect one of our probes to the VCC pin for the MC1488, and then check the remaining 2 pins on the power connector. Yep, check that out. The VCC pin is definitely connected to the 12 volt rail along with the 12 volt pin on the CRT controller, so that's our plus 12 volts. That means the other side of this MC1488 is almost certainly minus 12 volts, and yep, it connects to the second from top pin as suspected. Okay, so this board is almost certainly being run with 3 voltages, plus 5, plus 12, and minus 12 volts, as I suspected. That takes care of that. Alright, now for a harder one. We are looking for the header that contains the video output. This board is bristling with headers, but let's not allow ourselves to get intimidated by that. Going by the size and number of pins in each, we can easily rule out some of these. From experience, I found most computers like these tend to have the video header be 10 pins or less. You don't really need that many pins if you're just doing basic monochrome video. The most common configuration is to allow the connection of both a TTL monochrome monitor or a composite monitor. Composite is what I'm placing my hopes on finding. I don't have the skill to find out the connections for a TTL monitor. Composite means we only have 2 wires to worry about, video and ground. Okay, so looking around the board here, I think we can rule out a few offhand. J1, J2, and J7 are all 34 pins and are most likely either our floppy connectors or our Centronics parallel ports, which requires around 30 or so pins if I remember correctly. It's very unlikely video output will be on one of those. J10, J11, J12, and J13 are tempting, but note how they're all grouped close together right by those MC1488 and 1489 chips. The ad mentioned that the board had 4 serial ports, and I'm willing to bet that's what those are. That leaves just 2 headers to choose from, J5 and J9. And I'm kind of leaning towards J9. It just seems to be perfect. It's right up close to the CRT controller, attributes controller, and other related circuitry needed for video generation. J5 is nowhere near that stuff and seems to be connected to a 74LS374 flip-flop, which you would not typically use for video. Yeah, I'm pretty sure J9 is our prime suspect. One thing that will be a tell is if we can find a ground pin or two here. You need ground for video. Let's break out the multimeter and check. Aha, there's ground. Okay, so ground is pin 1. Now, finding our composite video pin might be a bit tricky, but we can apply some knowledge and hope it works out. I note the presence over here of an SMC attributes controller. I'm quite familiar with these. A while back, I bought a non-working Dynalogic Hyperion portable. When I got it, the computer itself seemed to work and would boot up from disk, but there was nothing on screen. I did all kinds of things like check brightness, contrast, etc., even hooked up an external monitor out back, but nothing would appear. I assumed the video board was dead. Then one day, just for kicks, I decided to see how alive the computer was by creating a boot disk that could be put into drive A, and with an autoexec file could call King's Quest III in drive B. I wanted to see if there were any signs of life from the video card if graphics were being displayed. To my amazement, it worked. King's Quest III came up and worked perfectly. But when I exited back to DOS, nothing. So what was going on? Well, I got a hold of the schematics for the display board, and I noticed that the display seemed to be divided into 2 parts. One part had the character generator chip and the other didn't. I reasoned that it must shift in and out of text mode, and thus text mode wasn't working while graphics mode did. So I followed the circuit around and eventually came to an SMC attributes controller chip. With the datasheet, I learned that these were used to modify the appearance of text. For example, if you wanted bold or strike through or so on, the chip would change it to that. All text had to pass through this chip and then out its video pin, pin 1, before going on its way to the display ports. On testing that pin, I found the video signal was bad, so I replaced the chip with what I think may be pirated knockoffs, but whatever, they worked. So with a bit of fussing around, I actually got the machine working. Now, the reason I'm telling you that story is because that experience gives me something to hunt for. Now, it's not exactly the same attributes controller that's in my Hyperion, but the video pin is the pin 1, just like it is in the Hyperion, and I'm hoping I can use that to sort of trace my way back to wherever the video connector is. Maybe. Now, if I'm right, all we gotta do is use our multimeter and follow from pin 1 and see where it ends up, I think. Nope, you had to know it couldn't be that easy. This board's traces bob and weave all over. Worse, while holding it up to the light, I discovered something disturbing. I could see the shadows of traces that weren't visible on either side of the board. That means this board is likely a 3-layer or more, rather than 2. Without probing every pin on every chip, I might never be able to find out where certain traces go because they're sandwiched in the middle somewhere and obscured by the components on either side of the board. That said, I did follow the tracks and diagram as far as I could, and they did seem to come over to the video circuitry, and then appeared to be heading back. I'm just going to have to make an educated guess that J9 is where my video is coming up. I'll hook up a monitor and then we'll see. Okay, so you're probably wondering how exactly I'm going to wire up a monitor to this header. Well, this is where being in the IT industry for years comes in handy. I've built numerous computers myself for various purposes over the years, and I have tons of these modern header connectors and wires. What I'm going to do is cut these loose and then strip the wires, which I'll attach to a composite video wire going to the monitor. These connectors all have double-headed ends. I could cut them apart, but it'd probably just end up breaking them all together. So instead I'll just strip one wire and leave the other unstripped. Then I just have to make sure I've got the right color plugged into the right pin. Once that's done, I connect my line going to the monitor and voila! Now let's get power out of the way. First, I need a connector that'll fit the DC power jack. I don't have the exact connector, but I have a few ideas, including these Molex headers. They're a little bit long and I'm a little bit reluctant to cut them up. Here's one from my parts box that's already been cut. It's missing the 4th pin, but I can work around that. This will let me connect my power wires fairly easily and ensure they don't cross. Crossing different voltages would be bad. To power this board, I'm going to be using this black brick here. This is a power supply from an Apple II clone that someone on eBay scrapped and sold for parts. I like these because they provide all the voltages one needs to power vintage computers of this era and earlier. This one has +5, -5, +12, and -12 volts. I'll use some jumper wires to connect the power pins on the power supply to the pins on the board with my unfancy broken Molex connector. For now, I'll just use +5, +12, and ground. That should be all this board needs to get going. I'm worried about being wrong about the -12 volts or the potential for shorts. Now, the pins in the power supply itself aren't labeled, but fortunately, along with the power supply, I also purchased an original clone motherboard, and that thankfully has all the voltages for each pin shown, so I can use that for a reference. Alrighty, all done. Okay, deep breaths. I'm very nervous about smoking this thing, but I'm pretty sure there aren't any shorts, and I know the power supply is good, so yeah, let's give it a try. Okay, so we got everything hooked up here. Basically what I've done for now is I've got my ground hooked up on the ground pin. We know which one that is. And then I've got my video pin plugged into the pin beside it here. And I'm just gonna go along this row and then across the top. And I'm just gonna hope that I find something. That's all we can do, right? And I got my power hooked up here, my 5 volts, my ground, and my 12 volts. Cross fingers, let's see what happens. Hopefully no smoke. Oh, not again. Must have crossed the darn power wires. Where am I this time? This looks like New Jersey. Definitely New Jersey. Okay, let's try this again. And nothing happened. Okay. Let's move to the next pin. It's not a promising sign. Next. Oh, that looks like a video signal. It's not a good one though. Now that could be the horizontal or vertical sync for a TTL monitor, so have to bear that in mind. Let's take the next one here. Go over. What do we get? Nothing. Blankness. Okay, moving along. That's pin 9. Let's see what we get there. Nothing. Okay. And we'll go around to the other side. Nothing. Okay. Let's go here. What do we got here? Oh, we got a sound from the screen, but nothing there. I don't know, folks. This is looking tight. This may not work out. No, I can see a very faint line there, but yeah, that's nothing. Okay, let's go here. Man, we're on the second last pin. 0. Oh man. Well, what else can we do? You know, as I said, I tried, right? Thought I had this figured out, but maybe I didn't. For all the marbles, here we go. 1, 2, 3. Hey, that looks like something. What is that? It kind of flew past there. That's a blinking cursor. Whoa, look at that. EQ equalizer ROM loader. Check that out. That's awesome. Having a little trouble with the vertical hole that wants to go right up to the top of the screen, but you can definitely see it there. Clear as a bell. Equalizer ROM loader version 1.1A. Well, even if I can't get it right on screen, that is awesome. That is proof that this board is alive. It's got a little bit of snow going on there. I'm not really sure what that's about. I'm gonna shut it down because it seems to be getting worse. It might be this old power supply. I haven't really properly vetted it, but yeah, that's awesome. This thing is actually working. I was not expecting that. I figured if it was a prototype, it might be completely broken. Might have been thrown on the trash pile because it just didn't work. So yeah, that's a positive result. All right, so now that that mission objective is complete, can we go 2 for 2? The next objective, as I mentioned, was to hook up a keyboard and try to interact with this thing, but that's easier said than done. For one thing, we know precious little about this machine and can't really take anything at face value in the ads, since the boards shown in the pictures differ substantially from this one. Maybe this board takes a parallel keyboard as the ad says, but maybe not. This one will be a toughie, but we're not entirely helpless. First, I'm going to go at this with a parallel keyboard in mind. Working with primarily pre-80s vintage computers, that's a format I'm used to. I wouldn't have a clue what to look for with a serial keyboard. You've probably heard the saying, great minds think alike. Well, that is definitely true of hardware designers. Hardware designers have definitely been known to borrow from one another. Sometimes they straight up copy another guy's work, other times the design is simply the most logical way to get there. So why don't we take a look at this schematic of the Insight board's prime competitor, the Big Board. Specifically the Big Board 2, as it was designed closer to when this board was designed. This might offer some clues as to what we might look for on the Insight board. The Ferguson has the data bit pins for the keyword going into a 373 flip-flop, and then into this Z80 counter timer chip. One problem is finding out exactly where the keyboard would hook up to. On the Ferguson board, the keyboard header was 25 pins. That's a bit more than is usually needed, but it does mean that our keyboard header could be any one of these 36-pin headers and on down. I think though we're still safe assuming these 4 headers are serial, and now we know for sure header J9 is video. I'm kinda liking J5 as a suspect personally, and the reason for that is because of those nice straight traces going right from there into this 74LS374 flip-flop. Remind you of anything? That's the kind of thing you'd like to see on a keyboard header. A typical parallel ASCII keyboard has 7 pins, representing the 7 data bits necessary to form the ASCII code for various characters and control codes. There's certainly that many going on between the header and chip here. You'll also need a strobe. The strobe is sort of like a doorbell. When you type, the keyboard rings it so the computer knows a key has been pressed and a code is ready for input. Other pins would typically include power. Keyboards use a variety of power schemes, including +5 or 12 volts or -12 volts. If we can find any of those up here on J5, I think we're on the right track. A lack of power pins would mean J5 is likely not the keyboard port, as most keyboards receive their power from whatever computer they're connected to, not a separate power source. First, let's look at those power pins. I already found the ground pin while snooping around off camera earlier. That's pin 16. So that leaves us with 3 other possible voltages to hunt for. We'll hunt for 5 volts first. Okay, nothing here so far. Aha! Pin 14 is connected to 5 volts. Okay, that's helpful. Now let's look for -12 volts. That's a pretty common one for vintage parallel keyboards. A lot of ASCII encoder chips that those keyboards use both -12 volts and +5 volts for power. Okay, so with one of our probes on the -12 volt pin on the power supply connector, and using our other probe to check the J5 header pins, yeah, I'm not seeing any -12. Alrighty, let's see if there's +12 volts then. Aha! Pin 15 is +12 volts. Okay, maybe by 1983 there weren't a lot of keyboards left using -12 volts? Now let's just check my assumptions about those data pins. Specifically, I want to check that there are at least 7 of them connecting to the flip-flop so that we have enough bits to form an ASCII code. I also want to check where each pin goes against the datasheet for the 74LS374 flip-flop and just make sure that those are going to inputs. If they're going to outputs, then that probably won't be for a keyboard. I'll use my DMM to trace each one to each pin of the 74LS374 and then diagram them. I'll speed this part up a bit so we're not here all day. Okay, so after drawing up and then redrawing a diagram for neatness, I have now vetted all 16 pins of header J5, and so far I like what I see. If we compare the notes I've made to the datasheet for the 374, it definitely looks like there are at least 7 pins connected to flip-flop inputs, just like they were on the Ferguson design, so that's great. Another interesting pin is pin 5. I traced this one along the board and discovered that it ran to one of the exclusive OR gate inputs of this 74 LS86. I followed the other pin and found it went to this jumper marked T2. Curious what this jumper was for, I traced the 2 pins it can connect our 7486 input to, and discovered that one pin connected to plus 5 volts and the other connected to ground. Now, why would that be? Well, a hint might be in the datasheet for our 7486 here. If we look at how this chip is set up, we can see each exclusive OR gate has 2 inputs and 1 output. Looking at the function table, we can see that the only way we get a high logic level off the output is if the 2 inputs are in opposite states. If they are both at a logical low or a logical high state, the output stays low. However, if one is high and the other is low, the pin will go high. So what relation does this have to a keyboard? Why would you want to permanently change the state of one of the inputs with a jumper cap? Well, one reason would be that keyboard strobe we were talking about earlier. Now, in most designs of this era, the computer has a strobe set up that is either set to a high or low logic state. The keyboard must be configured to change this strobe briefly to the opposite state. That's how a computer detects a key press. There was no one way to do this. Some keyboards were designed to bring the strobe low on key press, and others were designed to bring it high based on whatever computer they anticipated connecting to. Many keyboards were designed to be changeable between the two. The point is, for the strobe to work, the computer and the keyboard must be essentially doing the opposite thing when a key is pressed. And thus, just as some keyboards allow you to choose what type of strobe to use, some computers allowed you to change the strobe behavior on the computer to match what the keyboard was configured for in case you couldn't. That means if I had a keyboard that had a fixed high or low strobe, I could adapt to it with the computer rather than having to pick up a keyboard specifically configured for that computer. That means that if I had a keyboard with a fixed high or low going strobe, all I have to do is change this jumper so that when I press a key, the exclusive OR gate input that the keyboard is connected to will become the opposite of whatever the computer is set to, and thus the gate will go high, signaling that a key press has been made. At least, that's how I think it could work. The real test will be hooking up a keyboard and seeing if we can get anywhere. Okay, so why don't we just go for it and see what happens here. For this trial run, I'm going to be using this Southwest KBD5 that I have hanging around. These keyboards are great for this sort of thing. The KBD is a parallel ASCII keyboard that was designed as a general-purpose hobbyist keyboard, configurable for a variety of machines. It has this nice Molex connector which I can easily connect wires to without the need for soldering, which is great because I'm going to be probably changing those wires around a lot. Even better, each pin is labeled and well documented. There's no mysteries with this keyboard to figure out and thus pile on to the other mysteries of this board. The KBD does require minus 12 volts, but that's okay. I'll just tap into the minus 12 volt output of the power supply for that. For the rest of the connections, I'm going to use more of those modern PC header cables. I know where the 5 volt and ground pins are, and I have a theory on the strobe. I'll have to make sure that the jumper at T2 is set to the opposite of whatever this keyboard is configured for, which appears to be a positive going strobe. The 7 data pins are the tough part. Note on the Ferguson schematic, which we are using as sort of a guide, there are 8 bits, KD0 to KD7. This keyboard only has pins 1 through 7, and usually 7 pins are all you need for parallel ASCII. I'm not sure what the 8th pin is doing, if it's acting as parity or something else. For now, what I'll do is I'll follow the Ferguson schematic. It's probably too good to be true, but given how similarly things seem to line up thus far with this Inside Enterprises board, it's a better starting point than none. I'll start off with the assumption that what Ferguson refers to as the KD0 bit is actually bit 1 on this keyboard. For that 8th bit, I'm just going to leave it off or try tying it to the 7th. The goal here is just to see if we can get any sort of reaction from the keyboard. My hope is, even if it produces the wrong character, it'll produce something. Like I said, I'm probably up against some steep odds here anyway. The loader prompt that we saw earlier may not allow any sort of keyboard input. There may be no system monitor to break into and hack around. It may simply do nothing until the system finds a boot test that I don't have. In that case, we'll have no way of knowing if we're on the right track with the keyboard because keyboard input will be probably disabled. My best hope here is to try triggering the strobe and just see if we can get any movement out of the cursor. Whatever it puts out at the moment isn't really important. Any characters we see will give us the ability to sort of compare what we're expecting versus what we're getting and figure out hopefully which pins belong where in terms of the data bit pins. And then we can try adjusting a couple at a time just to try and get the code right. Alright, let's power up and see what happens. Cross fingers. Let's pray there's no smoke. No smoke! Excellent. Okay, time for the big key press. Drum roll, please. Nada. Let's try a bunch of keys and see what happens. Nope, nothing. Darn. I'll just break out my logic probe here and see if what I thought was the strobe is being triggered, in case I'm wrong about what that is or I wired it wrong. Yep, it's definitely reacting to key presses as I expected, but 0. I'm just checking the data bit pins here. I notice as I press keys the states change, but one thing that is weird to me is that when no key is pressed, I'm getting what sounds like a clock signal. I don't think the KBD5 generates those. I think for the data pins it just generates a straight up high or low logic signal depending on which key is pressed. Yep, those signals are coming from the keyboard alright. Well, as I said before, there's a few things we have to reckon with here. One is that I've simply got things wired up wrong. I'm sort of using the schematic of a similar computer as a guide, but it may not be exactly the same. In fact, after I started probing the circuit a bit more, I immediately noticed some differences. The outputs of the 74LS374 here don't actually go to a Z80 CTC as on the Ferguson. In fact, they go to this ominously empty socket, U201. U201 appears to be a socket for a 20-pin IC. The outputs of the 374 land here, and then they go across to the other side of the socket. I tracked these traces down to a Z80 dual-channel asynchronous receiver transmitter, or DART. So that seems to be one difference, and it begs the question, what goes in U201? Is there an IC that belongs there, or was this spot just a convenient place to have the traces flip up to the other side of the board and then boogie down to the Z80 DART chip? Another thing that's bothering me is that EPROM dump we did earlier, specifically what's missing from it. Looking through the inside EPROM, we saw the loader message, but that's it. We didn't see any sort of error messages. Usually you'd want to have at least a few of those. If this machine was trying to boot from a disk and failed, you'd assume it would pop up some kind of error, right? Or if you typed the wrong command? Otherwise, how would the user know there was a problem? I note that we have several such messages embedded in the Big Board 2 EPROM. We have what, disk error, and so on. So again, we're back to, is this board maybe an unfinished work? Is the EPROM software just an alpha with just enough smarts to get the basic board going? So many questions that can probably only be answered by a very select few.
Well, that's where I think I have to leave things for now, I think. I just don't have enough information to proceed any further, and I don't want to spend days, spinning my wheels, trying to figure out what's wrong, if there's some sort of design flaw or a component or some other thing that I'm missing. Now, nonetheless, I do think this board is a really interesting piece of vintage history. There were so many companies like Inside Enterprises in the early 80s and even before that, just tiny little companies that came out, they existed for just a moment in time and then vanished completely. And the only testimony that we have of their existence sometimes is just an ad in the back of a magazine. Now, fortunately, in the case of Insight, we actually have a real product here that we can look at, we can turn it on, we can get at least some sense of what it does. And unfortunately for now, maybe that's good enough. At least now a few people will know about Inside Enterprises' legacy. And this is where I kind of throw it to you, the viewer. If you know more than I do about these things, if you see I was doing something wrong, if you have any ideas on where to proceed, or maybe you've downloaded the ROM that I'm going to put up in the description, and you have some ideas on how that actually works, by all means, drop me a line in the comments. Just let me know that you're interested and you want to see if we can go further, and I will absolutely bring the board out, and I'll happily do whatever others suggest just to give it a try and see if we can get further than we did here. But for now, it's time to sign out and move on. I really do hope this machine was an interesting walk down memory lane for you, and as always, thanks so much for watching.